Hello, we are the members of the 45 of Capstone project. The topic of our project is federal funds rate prediction using interpretable AI. This slide lists the agenda of the presentation where I, Lavanshu, will be sharing the introduction and data collection parts. Manisha will be sharing the exploratory data analysis, topic modeling, and LDA to WAC. Renel will be sharing the machine learning models and BiLSTM. Gautam will be sharing hierarchical attention network, and Jean will be sharing CNN, BOT, and conclusion of the project. In this project, we built the Fed document dataset and applied NLP algorithms to evaluate and visualize the results. There hasn't been yet any study performing interpretable AI on federal funds rate, which motivated us to undertake this project. The objectives were to predict the direction of changes to the federal funds rate and visualization of the predictions. So what is federal funds rate? It is the interest rate for overnight bank loans set by Federal Open Market Committee, which meets 8 times every year. This interest rate has a chain effect on a number of economic factors which are important in regulating the economy. We reviewed the related literatures and found that gradually FOMC started releasing its written communications, which made it easy to analyze the text and perform sentiment analysis. For our work, we leveraged such studies that were earlier done in the financial domain. For highlighting the importance of the words, we studied the use of attention mechanism with models to explain the predictions that we got. Coming to the approaches and data collection part, we used over 50 websites for collecting the FOMC communications. The hypothesis of our project involved the prediction of the direction of the changes to federal funds rate under the classes such as lower, maintain, and raise. We collected the data for a period of 5 years from January 2015 to January 2020. While creating the dataset, we assumed that for each document lying between the tth FOMC meeting and T+1th FOMC meeting, the label would be equal to the decision that was taken in the T+1th FOMC meeting. We use the NLP techniques like embedding, feature extraction, and topic modeling, along with the models such as SVC, logistic regression, CNN, BiLSTM, hierarchical attention network, and BERT. For the data collection part, we generated the file structure on GitHub repositories and scraped the data from over 50 websites. To clean the data, we used parsers for HTML and PDF text and manually for removing the questions asked by the interviewers. We then categorized the data and built the pickle file for the dataset. Now I'll hand over to Manisha for continuing with the exploratory data analysis part.
Extensive EDA was performed on the dataset consisting of 1,362 documents having approximately 134,000 sentences. However, the data was pre-processed and threshold for words per document was decided to be 10,000 as a trade-off to minimize data loss and improve the model's training. EDA revealed two major issues in the dataset: the class imbalance and the neutral voice of the documents. As you can see in the first plot, we have captured the direction of change in the federal fund rates over a period of 5 years. Clearly, the green bars representing the maintained decision are quite dominant, hence the data is highly skewed towards the maintained label. To address this issue, we aggregated the data on the basis of speaker and FOMC reference date, resulting in 674 documents, which was used to perform all the experiments. The other plot shows the sentiment polarity of the documents for each decision using text law. The voice of the documents is quite neutral as it is mostly centered around zero point 0.1, leading to ambiguity while judging the sentiment. Topic modeling was done to discover different topics in the documents based on the vocabulary and use the topic results to get the query for hand. For this experiment, we generated a speaker-based and decision-based subset from the aggregated dataset and trained the LDA models for all the three corpuses after the necessary data pre-processing. The optimal number of topics for each of them were chosen based on the coherence scores and the interpretability of the topics. Topic modeling dashboard for the model summarizes data from the different point of views. From the results obtained, we can say it is really hard to predict the sentiment based on the topic results due to the similar vocabulary, making it hard for the models to differentiate. However, the interesting observation is that topics like US economy, growth, employment, banking policies, labor markets, education are popular among the speaker speeches, giving an idea that the Fed's decisions are hugely influenced by these factors. Inspired by the locality of word2vec and globality of LDA, LD2vec was implemented to jointly learn the word, document, and the topic vectors. For our experiment, we used 200 dimension embedding trained using LD2vec in combination with different algorithms to perform the sentiment analysis. The LD2vec, however, suffers due to imbalanced dataset issue and predicts only the maintained label. The next sections will be discussed by Renil, giving more insights about the results with ML and sequence models along with other experiment results.
This section talks about the various machine learning models that we implemented, like support vector machines, logistic regression, and random forests, with the TF-IDF features to predict the federal fund rate decision of the FOMC members. TF-IDF is basically a scoring measure which gives information about how important a word is in a given document. We make use of this information as numerical features which will be fed into the ML models to predict the end outcome of the speaker data. The table under TF-IDF with ML models shows that most of the models are giving FN score for only maintained class and rest as 0, which indicates that the models are predicting only one decision here. Whereas looking at the linear support vector classifier model with one versus all approach, it has the ability to predict all the classes by giving a better overall FN score, which made us choose it as our baseline model. Our dataset has class imbalance issue with 70% of the document belonging to maintained class. Since the models have hard time predicting all the classes with an imbalanced dataset, we tried few resampling techniques like upsampling and downsampling method. But these techniques didn't prove to be effective in improving the model performance compared to the baseline model. Then we tried our data aggregation by appending the speaker documents of each FOMC members together and observed that the model is able to predict better than the baseline results with the aggregated dataset. Then we did model comparison using support vector classifier and BioLSTM using different type of word embeddings like CBOW, skipgram, and GLOW. And we also made use of document embeddings as features using doc2vec and LDA2vec algorithm. And by looking at the observations from the table, document embedding generated from doc2vec is having more impact in making the model predict all the classes with good overall F1 score compared to the word embeddings and LDA2vec embedding. Then we implemented BioSTEM model with combination of pre-trained GLOW, trained GLOW, and document embedding features. And by looking at the observations generated from the BioSTEM model, it can be observed that doc2vec embedding with GLOW embedding features is giving a better test accuracy score of 75% and a good overall F1 score compared to the experiments that we did with the machine learning models. Now I will pass on to Gautam to talk about the hand model.
Moving on to interpretability, we have developed a hierarchical attention model to highlight the important phrases that signal the change in the Fed decision. This model uses two attention networks, one at word level and the other at sentence level. The speaker's words are encoded and reduced by the attention layer by focusing on only those phrases which are deemed to be important. This helps in removing unwanted noise in the document embeddings, which would otherwise bias the sentiment prediction. We have tried to create a set of 3 queries, which we hope would be able to distinguish between the 3 tables. We have narrowed down to focus on 3 aspects that influence the speaker's decision: education job, state of the labor market, banking systems, and factors influencing policy changes. Case 1. We tried to record the performance of Han without using any queries. In this case, the attention layer had no direction where to focus when it was trying to summarize the information. The document encoding would contain a lot of noise, which results in low performance. Case 2. We introduced the concept of query by manually creating 3 lists of distinguishable queries. Queries improve the model's performance on unseen data, with the F1 score improving from 0.78 to 0.84. Case 3. Since the model was trained in batches, each document should be made of the same length. This makes it more computationally expensive, so we manually crop the data to train in larger batches. The test performance increased marginally. However, cropping is very subjective and it cannot be recommended. Case 4. Here we have used topic modeling to the whole data. Training performance improved a lot, although test results are not significantly better. These results prove that topic modeling is as effective as subjective queries. Looking at a document highlighted by Han, we see the speaker talking about the US economy. The first query highlights words like growth, strong, benefit, which signal a good state of the current economy. However, the speaker also suggests that inflation is expected to rise in the short term. He also makes reference to words like recession. The frequency of words like inflation and recession, which are scattered all over the document, might have influenced the model to predict wrongly as lower. Inflation and recession are highlighted by the third query, which talks about the factors that influence the Fed to make changes to their policy. To compare the performance of Han, another interpretable model was used on our dataset, which will be talked about by G.
In this section, I'm going to talk about CNN bot and the conclusion of the project. We also built a CNN model and experimented with the hyperparameters and combining NLP features. Using the embedding dimension, we tested various combinations of back-to-back pre-trained glove, trained glove, and NLP features. Overall, the model had overfitting issues that resulted in 99% of train accuracy, but only a maximum of 68% test accuracy. The hyperparameters we tuned included kernel size, pooling size, optimizer, activation, and so on. We built the CNN models by adding multiple NLP features, including sentiment analysis, TF-IDF, and dependence parsing. The combination of back-to-back trained glove, sentiment analysis, dependence parsing achieved the best accuracy in CNN model. A state-of-the-art model bot achieved 79% accuracy in the test set. This is the best performance among all models. We built a visualization that shows which word contributes more to each predicted label. We compared several samples using both bot and Han models. As bot does not use topping modeling, the major contributing words are different from Han. In this example, bot correctly predicted maintain, whereas Han predicted a lower label. For a maintain prediction, inflation, participation, and unemployment were most important, whereas within the Han model, inflation was the primary reason for predicting a lower label. We selected the accuracy and F1 score as our evaluation matrix. Overall, we achieved between 67 to 78% accuracy in the testing set, and the F1 score shows that back-to-back works well for predicting rare labels. The accuracy from Han and bot was the highest among all the models. The limitations we faced included mismatched annotation labeling, imbalanced classes, and content ambiguity due to a neutral tone of voices. In order to address imbalanced classes, we explored up and down sampling. Mismatched annotation labeling can be addressed in future studies through human evaluation and annotation. In conclusion, the contribution of our project include, first, the collection of FOMC documents and speeches from over 50 websites to generate a new data set. Second, extensive experiments from machine learning models to the state-of-the-art models. And finally, building visualizations that give interpretable results. This is the first attempt in this domain. Thank you for listening.